judges? Okay. Perfect. So before we get any further, we just want to do a quick land acknowledgement today. We acknowledge that Manitoba is located on the treaty territory, the ancestral lands of the Anishinaabe, the Anishinaabe, the Dakota Oyate, the Denisovan, and the Nanticoke nations. We'd like to acknowledge Manitoba is the homeland of the Red River Métis. We'd like to acknowledge northern Manitoba includes lands that were and are ancestral lands of the Inuit. Last but not least, we want to mention that we respect the spirit, the treaties, and the treaty making, and are remain committed to working in partnership with the First Nations, Inuit, and Métis people in the spirit of truth, reconciliation, and collaboration.
Just gonna pause for a second, it's just not sharing.
Oh no. I think it's called okay. Should be good. Uh-oh.
Okay, well, let's stop now.
Oh, stop. Sorry, a little technical difficulties to start out. All right, back to where I was. So we've heard your concerns. The lack of water. How are we going to ship in water? It's snowing out, there's a blizzard. I can't get a vehicle out here. We can't barge something. The water tastes off. It looks funny. And last but not least, there's a possibility that we're getting sick. We can't figure out why. And that's what we're here for today. Remote community and the water solutions. Before we get too far into this, I'd like to introduce all the team members here. I'm Zachary Giacchino, and here's my team.
I'm Anthony Conte. I'm Rashawn Kapoor. And I'm Hassan Islam.
And together we form BCIT Consulting, and we're coming out from the British Columbia Institute of Technology. So let's kick it off.
The problem we've been given is the First Nations communities to address the drinking water crisis that exists amongst many First Nation communities in Manitoba. I would like to pose a question to you. How many days do you think you can go without drinking water before fatality? For reference, you can go without food for about 20 to 40 days.
Any guesses? A day?
That's even a stretch.
All right, well, you may be a little surprised.
Yeah. The human body can only go 3 days without drinking water. Some remote communities in Manitoba have been without access to reliable clean water for 6 years, and others intermittently for over 30. This is just absolutely unacceptable right now. It's a humanitarian crisis. They need water and they need it now.
Right, so the community that we're working with is the Tatasquoyak Cree Nation. They're in northern Manitoba, and they're situated around the Split Lake. And for the past 6 years, they've been under a boiling water authority. And because of this, they're not getting any clean water. So we need to implement a system that's going to be able to deliver clean water to them as fast as possible.
Jumping into the current system that's in place, we can see up here we have Nelson River, and that leads directly into Split Lake. As of right now, the Tatasquoyak Nation does have a water treatment system in place. However, due to multiple hydro dams created upstream of Nelson River, there's been a lot of sediments from the ocean, from the river coming downstream into Split Lake, which as a result has caused the water treatment system to inadequately purify the water for the Tatasquoyak Nation. So the current proposed solution that the government has in place is to migrate over to the sister lake here, Asian Lake, and set up a brand new water treatment system. However, this is going to cost millions and millions of dollars and take years. The problem is we have a water crisis and we need a solution now, as soon as possible.
Wonderful, and that's where we bring our proposed solution. So we have a 3-step process, with the middle being the most important. So we'll start with a form of intake structure, move over into a modular purification system, and have some form of distribution. Let's start on the first one. We have the intake structures. So why are we talking about this? Well, you have to get water from somewhere. It can't just come out of thin air. We've thought of 3 distinct possibilities, not only for the Tatasquoyak, but also for other communities. First and foremost, we'd have some form of still water intake. This would be plausible for locations that are bordering lakes. However, we do have a slight issue. The lakes do freeze. So we have to consider how are we going to do a maintenance plan so this can maintain operation. Next, there's other locations, specifically 2 others that we're providing the prompt, and these happen to be along rivers. So we need to be able to access some water through that. What's great about the river intake is that water doesn't freeze. It's moving. As long as it's underneath its top surface, we'll be able to draw that water. A huge issue with these is if the difference in elevation from the top of that water surface up to the storage tank is too large, a single pump can't make that head difference in order to get the water up there. Last and not least, we have the drilled wells. And these are super popular and also one of my personal favorites. What's beautiful about a well is that water is going to maintain its temperature throughout the year. Furthermore, what's great about a drilled well is it actually pulls water that's already been naturally cleaned. So it's going to have less impact on our next step. For the Tatasue, I actually looked into a possibility of a drilled well. I went on the Geological Survey of Canada and actually found that the area consists of silt and clay up to a pretty deep depth, up about 20 meters. The huge problem with those materials, they love water. They don't want to get rid of it. So the water has a tough time flowing through those materials. So we're going to need pumps that require more energy and are just larger than otherwise provided. So for the Tatasue, we'll look somewhere in between a combination of the first and second. Now to the meat and potatoes of our solution, the modular purification system. What this is a full purifying system that fits into the size of a container. Think of what you see on the back of the long-haul trailers, or even on the barges, and possibly the boats that travel interglobally. The beauty about these systems is we can specifically tailor the needs of both regions, or if we want to over-design entire areas, including maybe a province. Now I did a quick calculation for the Tatasue. Please note that this is a larger population, at around 2,400 people. In more remote locations, we won't be dealing in the thousands. So in this location, I went and I met both the needs, or the standards for both the UN human rights, as well as the Winnipeg water demand. And we found that that location would actually need a total of 10 systems. I'd like to note that these are based off of the stock size. So it sounds like a lot, but these can be tailored and customized when you work with the companies. You guys may see that Nibby Envirotech sitting at the top. And for that, I'd like to pass it over to my groupmate to describe it.
Thank you. Nibby Envirotech is a local Winnipeg company that is owned and operated by First Nations. They provide modular purification systems as shown here. The advantage of such systems is that they're easily scalable. We can add to them in parallel to meet demands. They can also be custom engineered so that they can purify multiple water intakes. Each community will have different needs in terms of the purification. Some may have sediments, some may have organics, and these can handle it all based on the designs that are given. Right. So now that we have it purified, we need to remember that it's still going to be put into the current infrastructure in the Tatasue community. And that is where they have systems. I'll pass it back to Zach for more.
So to get a little technical with you guys, these cisterns, as our research has shown, predominantly sit outside of the building envelope. So that actually causes more problems than it does benefits. The big issue is the ability for the sunlight to hit these containers, thus allowing photosynthesis process to happen, if we can remember back to elementary and think of biology. Now, what we're looking at is not using these cisterns as a storage, but rather a part of the big process. So this may not be having still water that's sitting there for months on end, as we'll have some form of continuous intake. Our solution to this is threefold. First and foremost, any location that we were to arrive to, we want to educate. What that means is following the Manitoba water storage practice and guideline. As we go through that process, they'll learn how to properly clean and drain these. Next, we're gonna go and do another little piece of the puzzle. And that's going to be providing them with water meters, specifically ones that can test different chemical constituents. What that's going to allow them to do is check whether, hey, do we need more chlorine? Or hey, the alkalinity in here is too high. From there, we have two crossroads. We can go the traditional chlorination route, and that would be through standardized guidelines, or we look at the process of portable aerators. Now, this is something that's been implemented on the coastlines of both the east and the west of Canada at our very remote light stations. Now, what this does is it increases the amount of oxygen within the tank, and what that does is make it so that all of the bacteria stays aerobic, meaning oxygen loving, so the process can occur. Once there's no oxygen, it turns anaerobic. At that point, we're gonna get the different colors. We're gonna get that bad stench. So that's gonna be the system that we're gonna implement. Now that we've had an opportunity to look at the solution, there's obviously a lot of the back end. And for that, I'll pass it on to my other crew.
So we'd love to talk a little bit about the sustainability aspect, which we're super excited about. We're going to touch on the three main pillars of sustainability through social, economic, and environmental. If you might pass it to the next slide. Jumping into the social aspect, we're first going to start off with a consulting strategy timeline, since we want to ensure to maintain effective and adequate communication during the whole process. We start off with an in-person consultation and providing a written report to receive your feedback as we're doing here today. Once we receive your feedback, in order to understand the concerns or any questions we may have, we'll get that back and implement that feedback. If everything is good from that point onwards, we're going to jump in and go into a community survey outreach with the Tatasweg people in order to understand what they need, how this project may affect them. And after we do that, we're going to jump into an on-site visit to assess the geography and determine with the First Nations community the best place to put these shipping containers, as well as initiate on the training process for the funding for the training process. One big thing we understand and recognize and want to respect is the First Nations, and especially the Tatasweg community, thrives and is very proud to be an independent community. We'd love to support that in any way we can by training the operators, training the indigenous community at the Tatasweg Nation to operate these independently. After that, we'll come in, implement, install, and execute the training process of these containers, as well as perform testing and analysis throughout the process of while the water is being purified through our system. Finally, once everything's all said and done and it's been running for a couple months, we'll escalate it to a large-scale government proposal to implement the system across multiple First Nation communities across the province. We can go on to the next slide here. We know that funding is a big thing, and we'd like to go over the fact that around 2 or 3 years ago, there was a class action settlement done between the First Nations people and the federal government of Canada. This results in a whole $8 billion dedicated towards First Nations drinking water and making sure that they have clean drinking water. Out of that $8 billion, $6 billion has been dedicated directly to support the creation and maintenance, as well as installation of water infrastructure systems across Canada. We strongly believe that as a result of our project, and with the province's, Manitoba's strategic plan for the providing safe drinking water, the government will heavily support this initiative, and by 2030 we'll be able to have these all across the province. The last part we'll be going into, the economic part, is the cost. In order to adequately train these Indigenous people, we're going to communicate with the Indigenous Services Committee in order to receive funding through the Circuit Rider Training Program. Now, this program we're really excited about because this is a direct source of funding from First Nations communities to train their people in water management operation. Finally, we'll touch a bit about the cost. As we mentioned previously, there is a pipeline being created from Asian Lake. That pipeline is going to cost $40 million and take years to implement. Our solution, bringing the entire proposal together, will cost around $8 million, and we'll be able to get this in under a year for the community. That's under 25%, a quarter of the cost that the government solution is being provided. I'd like to pass it on to the environmental section.
So our solution is also environmentally friendly. And the reason that this is the case is because there is a minimal damage to the environment. We can set up the apparatus just by using some stilts and a gravel plane near the lake bed. And this avoids having to do any digging or any planting, which can be intrusive to the environment. Another really important aspect of our design is its modularity. Because of this, once there's a more permanent fixture installed in the communities and they're getting consistent access to fresh water from those pipelines, clean water from those pipelines, we can actually easily transport this system into other communities who are still in need of clean drinking water. Another really important fact is that the Tatasweg community are actually nearby a water dam. And because of this, we can power our system with renewable energy. All right?
Awesome, and on to applicability. So we have three major points: quality, cost, and time. For quality, our system will be able to provide clean water that meets both the UN drinking water standards as well as the Manitoba drinking water standards. In terms of cost, it's coming in, as we mentioned, at less than a quarter of the cost of the permanent pipeline. Next is time, and time is of the essence. They've already been without water for over 6 years. We can have this up and running in approximately 9 months. Finally, to hammer this home, this system can be easily relocated and reused. So once that permanent system does come in, we can take this temporary one out and reuse it somewhere else.
So what have we gone over today? We've discussed the needs that these communities have. We've discussed our way of addressing them in a quick, timely manner. We've looked at some of the ways of the costing, some of the ways that this is impacting the environment. What is the problem? We need water. And when do we need it? Well, we need it now. So thank you for listening to our presentation. We hope we've enlightened you on our process and maybe even given some ideas. And if there's any questions, we'd be happy to answer them. Thank you very much. If there's a particular portion of the slide you'd like me to go to as well, let me know and I can skip back for you.
Can you just reiterate one thing, because
Yes.
and it's not because you probably didn't say it, I've just absorbed a lot.
100%.
So you guys are gonna bring the modular systems in and still use the same intake that is currently being used, or your banking, quote unquote, to like, where's the water coming from?
So our solution is to kind of borrow from what the permanent solution we use to go to a sea and lake.
Right, okay.
Because it
So
doesn't
that's
have the
flat.
sediments that are in the Nelson River are too high. So they're moving to a sea and lake, and we're gonna borrow that idea, go to a sea and lake where it's cleaner,
Okay.
easier to filter, so we'll be drawing from there.
And then, okay, so you're still so you have to still wait for that whole pipeline to be built, but you're cutting down costs because the modular system is less expensive than the permanent, like, or
So-
long-term water treatment. system.
Right, yes.
I do want to jump in briefly.
Yeah.
So this particular situation, we're copying the idea that they're going to go about doing, which is the water surface intake. But the reason that I projected and showed the three options is because this is supposed to be available for multiple locations. So let's say after Tataswek, we go and we bring it to another First Nations community. Perhaps they don't have a lake to draw from.
Right.
Then I have to look at either, okay, we're only restricted doing now in moving water or the drill, or the drilled well. So that's why I was going through that, because the bulk of our main part is the modularity and having that storage container as the
So that's how
system.
you're addressing the scalability of the,
Right.
your
Definitely.
solution, is that like, there's gonna be different methods of like water.
Exactly, that's exactly what it was for, yeah.
And further that, to just point about the pipeline, we won't need to wait for the pipeline to be completed because it can still be distributed as currently it is now by water truck, but it is now right there. So they can get access to it immediately. They don't have to wait for it to come in from miles away.
Right.
It's right there for them.
Gotcha.
Good question, thank you, so we can clarify that as well.
Yeah, sorry.
No worries.
Already started.
So for this particular application of modular solution, we need to get the water from the adjacent lake.
Yes.
And was there an element of actually having to pump that water to the site and to actually send power to that location to be able to pump that to the site?
Right. So
That
with these
one of the
systems, it is a challenge. These systems are usually placed on the banks of either the river or the water source. They do have generators that come with them that run on diesel and they provide power. As of right now, there is options to run conduit to the site. Could be a little more cost, but it would save them the power supply for the use that it does run. But in other remote locations where there are no hydro dams or no access to power, they do run on available diesel generators.
I do want to comment on the electrical aspect, because that's a great point. Recently, the Kiosk project was completed, which was a big hydro dam at the Tataswek Nations. And When we went and looked at the entire province, we looked at the power grid and noticed that with this hydrodam being installed, there are transmission lines and a power grid available directly there. There are many areas in Manitoba that are diesel zones, so we consider those areas where we primarily operate off of diesel generators. However, with the infrastructure being implemented for the hydrodam, it won't be as difficult to power these stations, as we already have a substation and transformers implemented right over there near Nelson River. Bringing them over to Hacienda Lake won't pose as much of a difficulty compared to an area where there would be no power, like a diesel zone.
Just as a metric, the nearest substation is around 2 kilometers away from the site.
Yeah, I know, given the time constraint in terms of, we've done exceptional amount of work in the 8 hours that you can be able to for this assignment. But certainly one of the, if you drill down into a little bit deeper, one would need to be able to evaluate what's more economical, sending power to Sea and Lake, or to be able to send clean water to the site, or send dirty water to the site and avoid that power at Sea and Lake. Yeah, and then deal with the treatment of the site.
It would have to be a
This is an analysis I wouldn't have expected. you to
Yeah,
be able to
yeah.
do at the time
But it
allotted.
sounds like that's already like a permanent, not part of like what's already happening.
Right, yeah, that,
They are planning to go to this.
yeah, that, the
Which is
future.
kind of interesting, they haven't done the economics on it, and
Right.
like, that's what they're doing.
I think if we were to obviously give it a plethora of time, the way I would approach that is also, like you said, looking at the dirty water, having that high sediment load. We got to look at what the maintenance costs are going to be at the intake, right? Because now we're going to have to replace everything way more. We're going to have to flush the system more. So, like, I would go about looking at, that versus, like you said, all that extra line, adding in the energy, so on and so forth. So.
Like, you have more long-term costs as opposed to like a higher capital cost.
Mhm.
I am hopefully not gonna grill you on this, but my question is more towards, the part like the cistern and like the maintenance of that.
Mhm.
And I just wanna say like it's a little bit optimistic to expect, every homeowner to, sort of do their own water testing.
Yeah.
When I read your report, like the first thing that came to mind for me is like, people don't even wanna, like people in Winnipeg hire people to maintain their pools so they don't go green.
Yeah,
Right,
yeah,
and now we're
yeah.
talking about drinking water, that's like an even higher threshold of like, maintaining cleanliness and all of that, like I think that's a really high expectation of like, I don't know, I don't even know if people like here would do it as opposed to like the northern community where people potentially have lower education and like
Yeah.
go back to understand what pH needs, like I went through engineering and I'm like, do I still
Understand.
know what that means, like?
Yeah. To draw some personal experience, I referenced the coastlines. I've had some experience working with government on the light stations, and like what you just said was a huge issue that we had to tackle was they have cisterns. They're predominantly though from roof capture. So in their case, there's obviously more of a high organic load that ends up in the cisterns. And I remember, and that's even harder because now not is it just the sunlight, some of the microbes that are in there, but now it's like the added leaves, added
It should juice things up.
Exactly. So I remember that absolutely is something. It is optimistic, and we had some trouble getting that initiated on the sites that we had looked at as well.
Do you
But
recognize
that's
that could be like a barrier or like one of the challenges?
Yeah.
The solution.
another big aspect is we didn't want to have the cistern act as a sole holder of the water, so we didn't want it to just be still water for months on end. The ideal was to incorporate it a part of the overall system, which would help in a little bit at least compared to if it's just fill it up and just leave it for 6-7 months, right?
So you're saying like that by incorporating the like pressure tank unit, like, it's like obviously like typical home.
Yeah, these
Things
are-
like, they don't
yeah.
have basements up there, right? So like that's one thing, it's like pretty limited on space. So
Yeah.
it's like making sure like, and like other people have proposed a similar solution, or
Right.
like part of the solution, right? Of like adding stuff to like the home sort of thing, and
Yeah.
it's, that could be a challenge too, right? Because housing is a whole other thing.
Thing to consider, yeah.
And
A lot of
people
variables.
living in there, right? So if people are like, that many people living in one room, do you have the room to add like this type of stuff? And it's not gonna
Yeah.
get damaged, kids everywhere and all that, right?
Yeah, yeah.
So, okay. Can you tell us more about the circuit trainer, like that program?
Sorry.
So
Oh, the circuit training.
trainer?
This guy
Yes,
here.
yes.
More information.
Okay.
Yeah.
Yeah, so it was really nice to look back into the policies of the indigenous movement towards First Nations receiving clean water. And one thing I went and read back on was in 2013, there was a policy that was repealed for the First Nations Drinking Water Act by the Canadian government. And since then, especially around 2018 to now, there's been a lot of initiatives and conversations between the government and the First Nations and Indigenous people in order to work together to provide the correct funding and metrics to allow and support these communities. And then one big thing that we recognize and respect is that the First Nations people are autonomous people and don't want to rely on someone, let's say in like Winnipeg, to have to come up there and check and maintain and inspect their stuff. So the Indigenous Services Committee, which was a result of UNDRIP, the United Nations,
Don't worry, it's okay.
did develop and implement the Circuit Rider Training Program, which is essentially just the source of funding directly tailored to educating First Nation communities in operating the water management systems.
So do people come to the community and train them? Do people have to go somewhere else and training? Do you know if?
It's very blended, so there's parts of it that's online, there's also on-site assessments. And the greatest part about it is that there's no like deadlines or connections on when to apply, so it's extremely flexible. Like if there's a First Nations community in need of it at the moment, or they need it in a couple of days, they can apply and receive it. There's no deadlines on when to apply.
Okay.
Yeah, on that note, I think you guys did a good job in terms of like using existing information and resources, for example, the training program, and also having different options in terms of water intake. My last question was also having to do with the experience. I was just wondering, talking about those aerators, and then in your report you mentioned a little bit about HVAC and chlorine level monitoring.
Yeah.
Is that all done by residents, or does somebody come and actually install the aerators?
So maybe there's a bit of a misunderstanding. The idea, yet again, to go kind of back onto participants, they're actually portable meters. And something that was hard within the time given, but I agree that someone may not understand what pH is, but I think someone would be able to read at least, compare a number against a manual. And that's where I was kind of in the direction of going, and then 8 hours goes like that. Yeah, so those things would be provided when we arrive or our team arrives, and that's all part of that training, right? I didn't expect it that every single person would do it. You would look to see, hey, who is more tailored to this? Who does the plumbing maintenance maybe? Because obviously there's got to be someone who's a handyman, yeah.
Like, who's the like person?
Exactly, yeah. So that was the objective, right? I wish I could have gotten that better across it. Just time constraints always hard to cram everything in, right?
Sorry, I have to take a couple questions.
One more question, because
Yeah.
I did look at your calculations
Yeah.
for how much water people need, and I'm curious,
Yeah.
the logic that you used because you did do, I think, 4 different.
It was 4
options.
different counts.
And so I'm curious
Yeah.
why you selected the one that you did.
Okay, so I looked, first I took Winnipeg. Now that's a tough one to compare against because we're talking a metropolitan city compared to a remote community. I wanted to look at it to get an idea. Now in the Manitoba guidelines, they have 2 checks, and this is similar across all provinces. You have a dwelling check where it gives you a value regarding, in this particular example, it was 3.04, was persons per dwelling. So we just used that Manitoba standard, took that, the number of homes which is provided by the Canadian government, and that's how I arrived at population based on the dwelling capita, that arrived at one value. Then I checked just the population. And if you looked at the numbers, they're massive, which makes sense because in a city, you're looking at anywhere between what I think the numbers are 250, 400 gallons is like the value that you see within the cities.
Yeah.
But we're wasting water like no tomorrow. Sorry to say, it's just the case. So what I did is I then went to the UN standards, and as you mentioned, the UN DRIP and several other standards are based upon those. So what I did is I compared it with that. Now what I found is it by the per capita times it by the household, it actually got a similar value to that of the UN. However, I still decided I would take the UN as that's something universally acceptable. Rather than just going Winnipeg, which is for a city that's 10-hour drive south of where the location is.
Okay.
So that's how the calculations got arrived to. And then obviously the base unit had 2,800 liters was the output per day. And I did a very quick simple calc to figure out how many. It was 9.2, you have to round out obviously. So that's how those calculations came
I
out.
was just curious how you.
Yeah.
How your logic, because I understand like the math, like, you know, I'm seeing the second option of like in Winnipeg, the 225 liters per capita per day. And it's, I think what I guess I was concerned about looking at your numbers
Right.
is that like, are you considering the fact that there are way more people in one house?
Oh yeah.
out there? And
Of
so
course,
then if
of
you're
course.
just looking at the population, so I'm glad that you used the number that's directly from the population
Yeah,
rather than
that's why.
per house. I guess I was just a little bit concerned that I'm like, yes, we're probably wasting water, 225 liters
Yeah.
a day, whatever.
Yeah.
But like also like 50 is like a drastic like difference.
It's a huge
from
number.
225. Yeah.
There's a range between 50 and 100, and I did take the upper limit on that as well. So that was taken out of those calcs, and then the Winnipeg was to substantiate. So it's not just doing a single line of calc and hoping you guys finally believe it, because you gotta have some proof to your work. So that's what that was.
Riding on the coattails of that question, I too checked the math.
Yes.
You're engineers, okay? You're gonna produce math.
Yes.
We're engineers, we're
Yep.
gonna check the math.
Yes.
I looked at my water consumption from the city of Winnipeg
Right.
website for the last several years, and I picked the highest consumption rate, which is double
Okay.
what I normally consume,
Oh, wow.
what's normally consumed.
Okay.
So I picked the highest number.
Yeah.
And then I converted it into scaled it downward
Okay.
to your system, multiplied by the number of homes
Okay.
and all number of people.
Yep.
And I came up with a number which was smaller than yours.
Okay.
Which was gave me a lot of confidence.
Okay.
In saying that your math was correct.
Okay. Nice. Nice. That's awesome to hear. It always gets scary when the numbers get checked. Okay.
So just know that your math is always going to be challenging.
Yes,
Yes.
absolutely.
Yeah.
Yeah.
Because I think that it gave you a lot of
That's
confidence that I saw the math.
Nice.
As an engineer, I want to see that.
Of course. Good. I spent a lot of time.
That really
8 hours.
solidify and validate some of the suggestions that you were.
And it's one of those, like, as long as you can, like, explain your rationale, like,
Yeah.
now that you're saying that, I'm like, yeah, okay, because a lot of the work that I do is very much predicated on that. I produce my economic, you're looking at long-term and this and that, or people are gonna ask, how did you get to that
Yeah.
number, right?
Yeah.
As long as you can, like, explain your thought process, and you're just like, I don't know, I landed there, and that's where we are, then, yeah, it's a good job.
I can say, when we were looking at the numbers initially, we were sitting down as a group and we're like, this is not happening. But we consider the nation and the fact that the Winnipeg number is like compared to how much an indigenous person on an urban area is using, it's gonna be, you know,
That's a big difference.
yeah.
Our goal was to get a solution that can be implemented quickly.
Yeah.
So we used the UN guidelines and just acknowledged that, you know, we said Winnipeg is going to be the unrealistic to provide that amount of water with a portable system. We got enough water there that meets acceptable standards, and that's good to get to when there's a full-time plant in 5 years. We just wanted to address the problem as quickly as possible
Yeah.
and with acceptable standards.
I am wondering, so I think for this community, remind me, everybody has a cistern? There's no pipe water, or like what's the situation?
Yeah. So from what we saw, or do you want to go?
Yeah.
Yeah. You go because I feel you read that.
Yeah, so from what I gathered, the current, as we mentioned, there is a current water treatment plant
Yeah.
off the river there. I would imagine that at one point it worked because they would have built it for a reason, but right now, because of the sediments from the, yeah, I've read, it was on the CBC report on this, that they had built multiple dams upstream that led to this becoming contaminated and then rendering the water treatment plant system. So they do have the infrastructure for pipes, but
So like the pipes are going to the houses?
pipes do go to houses.
So there is distribution?
There is distribution.
Okay,
So there's current
It's just
distribution.
not operational?
It's operational, but they say that it's coming out.
Well,
actually
that's
dirty.
right.
They have to boil their water.
Yeah, they have to do that. They have to boil their water, and they're currently getting fresh water and putting them in the standards from trucks. that's how they've supplemented their water needs for now.
And you guys?
I don't think it was a full line account. I wish I had
Oh,
gone
it's
to
like,
the end of
you
it.
guys have the pickup trucks.
It's just to show options. I was
Yeah.
on pace to get numbers and show all the trips and everything, like to do
Most
some
First
form of cut and
Nations- Yeah,
fill.
just, this is one for your information, most First Nations have a water truck, like.
Yeah, like a big rig.
Yeah, thing, and then I'm in transportation, and it's like what creates a beating on like the
Oh,
roads,
yeah.
right, cause it's so
So
heavy
heavy.
on
Yeah.
this road. And so it's, yeah, so then it's like, it's great that, we're using that as distribution, then it affects another part of the
Yeah.
infrastructure. Great, I don't have any.
Do you have a sense in this community, and this is very difficult in terms of researching, again, science a lot, but do you have a sense in this community that the maintenance was being performed adequately? And that the only issue was the water intake and not the maintenance of that site?
I can answer that to some extent. When I was looking into the kiosk project, it was really interesting because they did a workplace assessment, and there was some degree of controversy around the kiosk project. And when they did a workplace assessment, I think it was 2016 or 2018, I can't remember off the top of my head. But we did find that there was cases of harassment on that project. And that being a giant project in order to produce hydroelectricity must have caused a lot of sedimentation into the lake. And there could be a correlation between a poor workplace environment and maintenance of that dam causing to a lot of sedimentation, which resulted in the water treatment plant not working. Timelines do sort of line up with the 6-year boiling water advisory, but that is just two things that could be stretching.
Yeah.
That's just the kind of connection that I did
Yeah,
make.
also I would figure that if it was a maintenance issue, I mean, within 6 years, I figured they would probably have solved that maintenance issue. Like if it was feasible to, get that water treatment plant up to standards, I figured they would have done it quicker. So I would imagine. Yeah, so I kind of figured it was,
What's our biggest like hydroelectric dam to use our action surface causes?
yeah.
Thank you guys, we don't have any more time.
Yeah.